So happy Canada Day, everyone. I don't know if anyone cares, but so I'm going to talk about UI in Rust. This has been an interesting journey of mine over the past 18 months. So Rust should be pretty great for UIs, right? There's a number of reasons. So UIs are latency sensitive. You don't really want garbage collection, pauses, interfering with the user experience. Also, for anything that's on a battery, so like anything nowadays, it is in fact CPU constrained. Like you don't want to use a lot of battery life, even if you can hit the frame rate target. And even though UIs are usually not super life or death critical, users do notice when they don't work, and you don't want crashes and bugs and stuff. Raise your hand if you're frustrated with the quality of UIs in your life. Okay, cool. I'm glad I'm not the only one. So hopefully Rust can help because it should be good at all of those things, right? So my background really isn't in front end or web development or UI development or anything like that at all. However, a number of years ago, I found myself working at a small software consulting firm, which writes full stack applications entirely in Haskell, which is crazy, right? That's totally crazy. But yeah, so they use this library called Reflex, which implements a model called functional reactive programming. This was a lot of fun. Being able to use the same language for both the front end and the back end in one high productivity language is pretty addicting. And when I later got into Rust, I was, oh, no, that's not, hang on. Why is this not? Oh no, give me a second. Oh, this is terrible. The slides are not hooked up. Okay, all right. This is fine. Sorry for the interruption. Okay, so this is the slide you should have been seeing all that time ago. So anyways, this is why Rust should be great at UI, right? Okay, so yeah, I wanted the same experience in Rust that I had in Haskell. And I tried a few options and I wasn't super satisfied with any of them. And I'll get into the reasons for that. And I made the kind of crazy choice to try to write my own UI framework in Rust, which I thought would be pretty straightforward, but we'll see why it's pretty complicated. So Rust does not want you to write UI. I'm not the first one to have this observation. You can use all the usual tricks like arc and mutex, but I don't think you end up with something that's very pleasant to use. So you kind of have to try to do it some other way that plays more nicely with Rust. Oh yeah. Okay, so I'm going to go into some of the problems I had and how I kind of got around them. And I promise this is not just a pitch for my project. It's going to be more interesting than that. So, okay, so first I just want to talk about some common approaches to UI in general. These are not Rust specific, but we'll look at how they play out in Rust. So most platform native frameworks use this model called retain mode. And this basically just means you imperatively set up stuff and you attach callbacks to events and you mutate whatever you need to mutate. You can mutate the state of the application and other widgets, and it's just a big giant nest of objects. TTK has bindings in Rust that work like this. This is kind of just a little snippet. It's not the most fun thing to use, but I mean, like I said, you can do it. One very attractive mode in Rust is called immediate mode. So this has been popularized by eGUI. This is just basically you write code that just draws onto the screen. So you just call functions and they just draw stuff, and you do that every frame. This is super predictable. It's really simple. It's has very predictable performance and has this nice ergonomic benefit that you can just borrow stuff from your local stack. It's just stack frames, right? This is what Rust is really good at. The downside here is that it uses a ton of CPU to redraw everything, and probably GPU to draw everything every frame. And also, it's kind of hard to make it work really well with local state. If you want a component to have state local to its definition for modularity, it's a bit hard to make work with this. So another kind of related model is called the Elm architecture. This is from a language called Elm, which compiles to JavaScript. So the way this works is you define a view function over some application state type, which returns a description of the UI. And then you can also, so events returns this like message type that you define. And then separately you define a function which takes a message and the old state and it updates the state. So this is very testable. That's like one huge benefit of it. Similarly to media mode has the downside that it's very hard to make it work with local state. And also it's not super efficient to allocate these large view trees every frame. It's kind of like, I mean, it's better than drawing, but it's like a garbage-oriented architecture. Okay, so based on the kind of things I saw, these are the goals I had. Like, if nothing is changing, then I thought there should be no allocation. Like, allocation should be for when stuff happens. And also, we want to avoid diffing trees. So the way that Elm architecture works is like, after each frame, you do a diff of the previous view and the new view, and you like apply that. That relies like on allocating these big trees and diffing them, and I think we should avoid that. I also want component local state. This is just important for modularity. And it would be really cool if we can like borrow data from parent components just like we can in media mode. So, okay, so this is like what I tried first. This is kind of like a rebranding of functional reactive programming in the modern web world, is this idea of reactive signals. So a signal is just some time varying value. So this like data string signal can be it's one like value at a certain time, and then it can change over time. And you can like map, like there's a whole set of combinators like you have for iterators. So this is kind of what it might look like. I built a whole framework like this, and then I got like totally frustrated by this problem. So other people have noticed this too, which is that you have to clone a lot of stuff, and that's okay in general. Like I'll write .clone is fine, but it interacts particularly poorly with closures. So in this example, we have this optional combinator, which you can imagine like it takes a Boolean signal and it says like, okay, I'm going to show the widget if it is true and hide it as false. And there's this function which runs every time it changes from false to true. And we have to clone the name signal just to move it into the closure. That's already pretty verbose. But then because the function is invoked multiple times, we have to clone it again each time the function is run. And it can be really annoying to reason about like which of these you need, the inner or the outer. Like you just get some error that's like, oh, the thing isn't copyable, and like which one do I add? It's pretty annoying. The good news here is that there's a semi-serious effort to fix this in the language. So there's talk of adding a new trait in the copy clone family that would be automatically inserted for cheaply clonable things. So like in this case, actually, the signals are probably something reference counted. Reference counts are like cheap to increment, so we can use that in the infrastructure. So maybe this will become a viable approach in the future. On the other hand, like if the signal was just something copyable, like reference, then we'd be happy, right? So that would be really cool. The problem is that it would become something self-referencing inherently. So just looking at that example we had a minute ago was kind of contrived. The application owns this greet more component, and it owns its subcomponents, and also a component owns the signals that it creates. But the subcomponents also have references to the things that are the signals that they use. So that's just like reference to the parent's data. So you can't do this in, say, Rust in the general case. But wait a second, there is self-references in Rust. It's called async. So it's not actually totally crazy to think of a component as a future which you can pull, but it never returns. Like it's just like a task that's running until it's dropped, right? Kind of makes sense actually. So you can imagine it looking sort of like this, maybe with some more macros or something. But yeah. So if we were going to have a framework like this, we need some combinators to build our components out of. So you can imagine this with some combinator. So this would be like it's kind of like a flat map for option, like so if you have a signal with an optional value, it would only show the thing inside if it's the sum, and if it's so it gives it a signal with the value inside the sum. So this is like an advanced version of the optional combinator from before. So this should be possible, right? So we can actually define it just fine, but we can't use it. So the problem is that the closure that we pass in, it has to work for any lifetime for that signal that it takes in. So in our example, like where we use it, that name parameter has some like unknown lifetime, and the future that we return, it depends on what that lifetime is. But when we define with sum, we just have a single type parameter that has to be like independent of the lifetime. Like it just has to be a single type. And so that's not possible, and that's why Rust tries to infer it to be like a single type, and then you get this error. So what we would really need is this few parameter to be a family of types, which depends on the lifetime. So in type theory, this is known as a higher kind of type. Haskell has these, some other functional languages have them, Rust does not. So I was complaining about this to a good friend of mine, and he put it really well. He said, languages should have the convex hull of the features that they already have. So like there's all these features floating around, and I kind of see it like this, like these features surround the missing one, and you feel like it should be there based on your experience, because it kind of would be natural that it was there, and it's not. And in fact, I think the evolution of Rust has largely been guided by this principle already. So like all the improvements we've got to the borrow checker over the years kind of went like this. But actually, we do have higher kind of types. So you can do it like this with generic associated types. So you have this dummy type that just defines the generic associated type. And if you quantify over the dummy type, then you're kind of like quantifying over the generic associated type, which has the like extra quantification you need. This is just like totally impossible to use in practice. It's like really overly explicit. And in our case, it probably doesn't even work because async types are unnameable. So we wouldn't even be able to write these down. But we can imagine some hypothetical syntax like this, where we'd be able to quantify over a family of types. So as a Haskell programmer, I had to put this here. Like, personally, I think Rust is in denial, and we'll add this eventually, but I don't call the shots, so I don't know. So even though I ran into that problem with async, I was sort of foolishly determined to try various like alternate forms of the same fundamental idea. This did not, like, ultimately I just kept running into the same issue before I fully articulated it to myself. And I kept thinking I could work around it one way or another. Like, but yeah, ultimately it was fighting against something that is just pretty deeply baked into the language at this point. I even managed to crash the compiler several times. So like, if anyone tells me Rust has good error messages, like I will fight them. Raise your hand if you've done this, crash the compiler. Okay, okay, so I'm not the only one. Yeah, okay. It's not that easy, but like, I've not done this in any other sort of production grade language. So if any compiler developers are in the room, like, I just want to say, like, please fix these bugs before you add new features. Even though I want higher kind types, like, I want this fixed first. Okay, so it really did take me like 15 failed designs that I threw out. I have all the Git repos to prove it, and like 18 months. But I did arrive at something that sort of worked. So I want to talk about how I got there. So really, I had to reason backwards from all the problems I had before and the constraints that Rust has. So really, I wanted something that feels like immediate mode in terms of the ergonomics of it. So I can just like use borrowed data, but also if there's component local state, then that needs to be retained across streams. So that can't have these like lifetimes that are part of the definition of the view, right? So that needs to be a separate static type. So that needs to, so first of all, we need to think like, okay, our view description and the state that's associated with a component need to be separate types. And then also there's another property of immediate mode, which kind of makes it attractive, which is that as we describe the UI, we're not like building up a structure, which is kind of accumulated in memory. We're just directly drawing onto the screen. So basically what we're doing is immediately consumed by the framework. And then analogy here would be like, in terms of what I want, is like, as we describe the view, it's just immediately applied to the state. There's no like building up the whole thing. So it might look like this. So we have a view type, and this could have some captured lifetimes in it, but it has a state type, and that's static. And we can build it like to generate an initial state, and then after the first iteration, we can rebuild it by just like applying it to the old state. So just as an example, like we can imagine like a string slice over any lifetime could be a view, and its associated state type would have an owned string attached to it. And when the old string and the new string don't match, we would update it and like also update it in whatever like this sort of platform backing thing is. So we try it. Yeah, so we actually can do the basic thing we wanted, which is to have views which capture some input lifetime. So this view string thing, which just uses the instance we just defined, like that works fine. However, for fairly obvious reasons, we can't capture a lifetime of a local variable and then try to return it. Like that won't work because you can't have that lifetime outside the function. So I've been talking about capturing for a while, but I haven't really like explained it. Maybe people aren't familiar, and it's actually pretty subtle how it works. Like I thought I understood this, and then I read all the rules, and I did not. So whenever you have infiltrate in the return position of a function, it automatically captures any of the generic type parameters. All right, so type parameters. Okay, that's important. So in this example, even though the skip first function, the return type just says impl iterator, that looks like it should be a regular static type, but this doesn't compile because the I that gets filled in there is this iterator that is dependent on data, and that has that lifetime, so it's kind of captured into the type, and so we can't return it. However, the rules are kind of interesting because lifetime parameters are not automatically captured. So this actually compiles. And the reason it compiles is because this A lifetime is not actually used in the result. And it's also not captured. So this just works. But if we want to, we can explicitly capture lifetime. So I've been doing that with the sort of view examples already. Okay, so back to our example that didn't work. Maybe we want something like this. So what if we could delay the borrow so that we don't actually return something that captures the lifetime yet, but we only do that later when we need to. So it would look something like this with combinator. So there's a lot of code here. You don't need to read it all. Like basically the idea is this: we have this context type that tells us whether we're building or rebuilding the view. And then a function over that can be packaged up as a view, and you just like implement the cases. Okay, so let's try it. It doesn't work, and the error is actually pretty unhelpful. If anyone understands this error, like raise your hand, I'd be really surprised because I don't think it's very helpful. Okay, so the hint is in the like CX parameter, the type that it thinks is there. So the +1 type, the lifetime there, it's getting captured on the state associated type. It doesn't really explicitly say that. It says it's on the view, which makes sense. We know that the problem can't be the view because the view is immediately consumed when we run that cx.view. So like a lifetime captured there is fine. So it must be the state type. So just a reminder what the view trait looks like. The state type is static, so it really shouldn't be possible to capture any lifetimes on there because we said static. Static means there's no like other lifetimes in there. So I thought this was a bug. I found a bug report, basically the same thing. I'm still not totally sure if this is actually a bug or not. Yeah, so the person who reported this, they were able to fix this by putting a static like bound at the use site, basically like saying it louder, like it's really static, like trust me. So like here, I tried basically adding static to the state at the use site, but this in my case didn't work. And the only thing that's changed is now it says on CX, it says that it has this type, the state type has this view +1 plus static. Now that's just wrong. That doesn't make any sense because it can't be static. We never said the view was static. We said the state was static. So this definitely looks like a compiler bug. I mean, like in terms of at least the error message seems wrong. But it kind of shows what went wrong here, which is that the compiler is conflating the lifetimes on the view and the associated state type. So this is how it works, actually. In hindsight, this seems pretty reasonable, right? Like, if we just say that the state is another opaque type, and that type does not capture anything, then it works. Maybe the not obvious thing here is that you can have nested infiltrate like this. This is actually kind of strange, but it does work. So yeah, this is how you can do something like this. And if you thought it was strange that lifetimes are not automatically captured, but generic type parameters are, then you're not alone, because the 2024 edition is fixing the inconsistency. And that would break the code we just had, but thankfully there's this new use syntax where you can say exactly what you capture. You can list lifetimes and generic type parameters. I think this actually makes a lot of sense. This is pretty nice. And yeah, so the state, you would just say it uses nothing. That seems pretty clear. It's what we want. Okay, so I promise this is not just like a pitch for my project, but I want to like just give a brief sneak peek of like how it looks. So yeah, it's just like a basic web app framework. You can't like make like mobile UIs or anything, like, yeah. But in principle, those kind of ideas I've talked about could apply to any sort of backend. It's not specific to how the DOM works or anything like that. Yeah, so you can define like really easy, like defining HTML elements and attributes is pretty easy. There's no macros, like Rust format can format this. It doesn't like give up. Like that's the problem. That's an annoying thing I found a lot of frameworks is they're just like, oh yeah, use a lot of macros. Events give you direct mutable access to the state of the application, and this is like really convenient. You don't have to have that message type. I mean, the message type is fine, but it's just like extra boilerplate a lot of the time. We can have local state, which was not possible in a lot of other models. So we can have like an initial value, and then inside the definition, like the body, we get the current value, and also in the event handlers, we get also a mutable reference to the local as well as the global value. We can have a list over anything iterable. It's pretty easy. Yeah, we can compose, use like kind of how you would expect. Yeah, just the usual warning. This is like totally like pre-alpha quality software. Like, don't run off and build your next app with it. It's not ready. But yeah, I'd be very excited if anyone wants to try it. I think it's a pretty cool point in the design space, which has not been explored yet. And yeah, I'd love to hear your experiences, and PRs are welcome. So questions?
Any questions?
Just wondering why you just didn't use another off-the-shelf one, UI framework, instead of doing it yourself.
Yeah, I mean that's a question that is a very logical one. Like, I can't say that there's any like, as a rational human being, you probably shouldn't build your own UI framework. This is, but like I will say, this is just a side project. Like, I was motivated by wanting to build my own like side projects with it, so I didn't have like the pressure of like a startup runway running out that I need to like, yeah. Yeah, I think this is better, but that's obviously subjective.
Thanks for the talk. It was great. I've done a bit of I've been using Slint for the past year or so. I don't know if you've heard of that.
Yeah.
And when you look at their generated code, it's got all those nasty. It's got lots of nasty stuff, but they kind of got around it by using a domain-specific language, so to hide all that stuff. Have you even considered doing something like that? It's commendable that you're not using macros and all that stuff.
Yeah. Yeah. So actually, I do think using a domain-specific language is another strategy that makes a lot of sense, because you can generate exactly the kind of code that you want in terms of like the operational model. However, that's just like super heavyweight. Like, yeah, there's no specific reason you shouldn't do it that way, I would say. But my experience is like, whenever I can use just native Rust functions, like Rust is very good at abstracting over stuff, right? With the traits and the type system. And if it can work that way, that seems like a benefit to me. But yeah, there are escape hatches in other models.
How does this work? Yeah, thanks, Chris Hawk. Curious as to what the differences between your framework are and Ralph Linus with Xylem and his whole research thing.
Xylem?
Yeah.
Yeah. Okay. So sorry, I forgot to mention Xylem. Actually, that was in my notes that I couldn't read. Okay. So I stole some of the names, like that view trait and state type. I totally stole the names from Xylem. So credits to them, and I highly recommend anyone who's interested in this stuff to check out Xylem. The big difference from Xylem is that the view objects in mine are never deeply materialized into like an allocated tree. So Xylem works on the same kind of like React, like virtual DOM principle, where you allocate a big tree and then you different. It's kind of like the Elm architecture. So yeah, I would put it generally in the category of the Elm architecture. But in terms of the ergonomics of using it, it's very similar and like it's has a lot of shared like principles involved.
Last question from anyone? All right, we'll give a massive hand.